Good afternoon, guys. My name is Sahil Kriplani, and I'm a programmer analyst at TechRaise Labs. And this session is about reverse engineering an app that we use almost every day, and we use every day the app, and it is Instagram that is designed by Meta. We'll try to answer engineering questions from it, such as how does it work when millions of videos are uploaded together? How does the authentication work in Instagram? Because and many more such questions, because Instagram is more beyond code, and it depends on such engineering decisions. And this is a roadmap that I've created where we'll start from uh, right where the app is open from when we tap that icon on our phone. Then we'll go through authentication, the home feed, infinite scroll, the algorithms, everything. And I hope it is a good session for everyone today. So we'll start with the uh, opening of the Instagram. When you tap the icon, how Instagram's own code will not run yet. First, it will bounce your DNS to the nearest data center because the distance is directly proportional to the latency. The distance increases, the latency will also increase. Then there is a CDN that holds copies of photos and videos of static files worldwide. So, for example, if you download a photo that is on an American CDN, your phone will take longer to load rather than if you do it, that image is of an Indian CDN. So that is how a CDN works. Then there are load balancers that spread requests over thousands of identical servers, and the sick ones are automatically skipped. As soon as a load balancer finds the server that is best fit for you, the API gateway is then the single front door where the rate limit is put and you are directly entered into the app. Next, we'll move on to the authentication system of Instagram, where once you have to prove it and then it stays in the server. Like, for example, when uh, when the password is hashed, that is intentionally slow because your password has to be stored in the system. And once you store the password, you get a token, which is a signed note saying that you are this user and you can log in whenever you enter this password. So any server with a key can verify your password. There'll be no lookup, there'll be no shared memory. And since this password will be stateless, it will be very scalable because the RAM would pin you to one machine forever. The only trade-off is that if the token is short, there are there is a limit leak. Otherwise, there is no trade-off as such in the authentication of Instagram. And all this can also be done using the caching of the Redis server, which is allotted in Instagram. Now, the opening, the home feed, when you enter the app, how the home feed is loaded, it is not directly, there are more than 500 accounts that load while you are on the home feed. So all the accounts don't refresh every time a new post is created. Your system is refreshed as soon as or whenever you click on the refresh button, or if in your older device, if there is a refresh button, or when you reload the screen as a whole, only then it reads the accounts. And not all accounts, the accounts which are on your recent memory, those will be read. And the new post, if it is any created, they will come back directly onto your system. And it uses SQL for graphs and NoSQL for timelines. And Redis is used for caching. Redis is a very crucial role which it plays inside of apps such as Instagram and Twitter and so on, because it is one of the best technologies you can use for caching, and it creates very uh, future-proof and scalable systems where you can cache everything, and it also does not cause a security threat. Next, we'll read about the infinite scroll. The infinite scroll is somewhat similar to pagination, but it does not work how pagination works, because if, for example, there are 10,000 rows, so in one page there are 100 rows, the page limit is set to 100. Now when I skip to page 2, it will create a new page and new 100 rows. So if when I'm refreshing or when I'm setting the page to 2 and some new records are entered into my database, then by that time what will happen? I can either get duplicates into my new page, or I can skip some of the entire rows, which is why infinite scroll is a promise similar to pagination, where offsets are very wrong. New post, where a new post will shift the list and the cursor points to an item, not a position, where the last item is a post about Apple iPhone. So when I click on when I scroll down and try to go to a new page, then the cursor will be pointed to the last post about the iPhone, not to the page. So that whenever we load, it shows that after this post, whatever new has come or old has duplicated, we'll have to show them accordingly. And in pagination, which Instagram uses, the prefetch is page n plus 1 while the user is still reading page n. So that is something we'll have to keep in mind. Now we go to the one of the most crucial topics in engineering Instagram, which is when how does Instagram upload a reel, or when we upload a reel or a video or a photo, how does that work when we upload it on Instagram? It does not directly be uploaded to the API. For example, a video is 180 MBs and I click on upload button. So 180 MB video of one user, such 10,000 users upload it on one single time. The server will crash almost instantaneously and you will never get to see the app. And if it does not even crash, then all of the major working bytes or working threads, they will point to the video upload process. So normal request will not be able to send, like refreshing the feed or refreshing the algorithm, anything, any such request, they will not be able to process. So we cannot upload the video directly to the API. What happens is, once I click upload from here, I get a pre-signed URL, and that pre-signed URL is sent to the API or the backend, and the video is directly uploaded to the object storage, which can be anything. If, for example, we use an S3 bucket, that will be an object storage for a production site. So the API only gets the pre-signed URL from the bucket, and our video directly goes to the object storage. The video and the API, they do not directly contact each other. They contact each other through the pre-signed URL, and then a Kafka event fires where the app and the API gets to know that, okay, this video has been uploaded. Now, after the process is completed, we will have to post it to the Instagram servers. And that is how uploading of a reel works for Instagram, or an image, or an audio, anything that you upload. This is how it works. And just to be very right about one thing, once the API is done, and the request is ended, that does not mean the whole work is completed. The video is processed after it is uploaded. So once as I said, in the once the API is called, a Kafka event is fired that a video is uploaded. So once the Kafka event is fired, it will run 4 single simultaneous events, where one will transcode the whole video, one will create a thumbnail, one will create a safety check that the video does not violate Instagram policies regarding anything, be it abusive, be it violent, any content, and one will auto tag the video accordingly to the topic it has used inside it. 4 such single threaded events will fire into one major Kafka event. Once all of this is done, then the Kafka will do 2 things. One, it will create an event saying post is published, where your Instagram post will be published directly. And secondly, there'll be a push notification released to all your followers. Whoever follows you, they'll get a notification saying you have uploaded this video or this reel. and they can now watch it. So once the API is called where you upload the video, the work doesn't end there. The work ends only after the video is being processed into the Instagram servers. Now we move to the next part, since we were talking about video and photo uploads. So this is the right segue to move to the part where we talk about likes and notifications and how those systems work. See, in likes and notification, there are three different things when we see Instagram as a broad architecture. One, your likes are never repeated. For example, you've liked a reel or an image. No matter how many times you like it again, it doesn't change the fact that you've already liked it once. So your like count will always, from your side, it'll be one. You can unlike it, but you can't double the likes. Now you double tap. So what happens? There are three different events that fire simultaneously in the backend. One, your like is stored. Second, your Redis counter is increased, where your likes are cached. So the likes of the posts are cached. So another when once you like again, another like is being added to that Redis counter. And the third thing that happens is a Kafka event fires, where the user who posted that video or image, he gets a notification saying that your image has been liked by this of your follower. So there are three simultaneous events that fire, but there are three different rules to it as well. It doesn't mean that just the like is increasing or the like is storing. They three are independent effects, but they fire on one major event. That is what Instagram is all about. Basically, it is about event-driven architecture where on one single tap, there are many simultaneous independent events that are firing, which we have to take care of. And these are not just coding decisions. You can implement this feature, but these are decisions that are to be done before the code is even tried to complete, so that you can scale out, you don't scale up in apps as such. So yeah, that is one of the major events, like and notification, how it works on Instagram. Second is the real-time chat. It works through two things, which is a WebSocket, and a second is a pub/sub channel, which is a publish and subscriber method. Basically, what is a pub/sub channel is there is a publisher, there is a subscriber, and there is a broker in between. So I post a message, it goes to the published channel, and then I can move on with my different tasks. Then the broker will take it to the subscriber part, and the subscriber, once it is into the subscribers directory, the subscriber can read that message. So for example, you have messaged, the message is stored in the Instagram's publisher channels. Now you can leave your chat and you can go to a different event altogether. You can start and scroll reels, you can go to the record a story page, you can go to whatever, but your message is gone. Now after that, the connection registry for the user's gateway, it will take it to the subscriber channel. From that gateway, it will go to the user you have sent to the message for. And after that, once his channel opens, then he gets the message and he can read. So the two things are independent and it is readable. So you can't send, uh, I mean, the duplicate messages you send, that is two different messages, but one message can never be the same, which is the point I've been trying to get to here. Now, Instagram, how now we'll move on to the most interesting topic on Instagram, which is the recommendation part. And how does the explore section work? Because you've seen in memes or in places where users just try to see each other's explore, you can get an idea of what the user has been seeing recently. That does not, it is a funnel, it is not a search. Basically what happens, your recent items, all your recent reels you've been seeing, or the post or the type of audio you've been listening to, it is all stored into Kafka events or an event stream where not the most you see it, but the last you've seen, all that thing comes into the explore feed that you have. For example, if you've been For example, if you've been watching dog videos very recently, but overall you watch a lot of gym content, that doesn't matter what you watch overall. The most recent videos or images that you've watched, for example, that is the dog videos, they will come onto your explore because it does not keep a track of what you watch overall. The last you've watched becomes your explore for the next time, and it goes on so that it doesn't have to keep a track of whatever you do every time. It just has to keep a track of what you did last, and which is a very nice independent engineering decision because my servers are not always dedicated to what you are watching, just the time from which you logged off the app or logged off the system. Just from that time to 10-20 minutes before what you are watching, I just have to keep track of that. Once that is done, I can create a new explore feed for you, and it is really an intriguing system of how they've built it. Next, scaling out. As I said, Instagram scales out, it doesn't scale big. For example, I have a code. Now today I have 100 million, or for example today I have 10,000 posts or a million posts every day and 100,000 users every day. All right. So now tomorrow suddenly I get 2 billion users and 100 million, 200 million posts upload daily. What do I do? Do I just up the server size and everything works? It does not work like that. We have to scale out. Each of the user IDs sharded so that we have different app servers which are running independently. Now logic will be very easy to copy into all app servers, but state will be not. So the user ID, that is the reason user ID is sharded into different shards like shard A, B, C, for example, and they are specified and dedicated to different servers. Now, if the user count and everything increases directly as such, we just increase the server load into that specific server, and that region or that region of users which is using the Instagram, they will run the app very smoothly, and the others will too because they do not have the size of users which is required so that we increase the size of the servers. And yeah, that is how scaling out works. And it is designed to cache at every layer, so you do not have to store everything into one single system. It is cached. You can rewrite it, you can store it, and you can manipulate it however you want. And now, for example, it is one of the most asked problems if you go anywhere. Like if there is an influencer who has, say, 1 million subscribers or 1 million followers, and he posts a reel. So now, if 1 million followers like that reel, it does not directly, call 1 million API calls for a uh, write event. It calls all of those accounts are pulled and they are first called into a read event. And then after the read time is completed, after that, the write time is called because different app servers independently do different tasks. So everything is done simultaneously and it is shown that it is done very smoothly. But if we think behind and what is working in the backend, there is a lot that goes into scaling out Instagram. And these are some things that are very crucial for an app after it is built. We have to build such things so that we can measure how the app is working or not. One, they are metrics. They are just numbers, rates, there are errors, there are latencies. They tell you immediately if something is wrong. And in metrics, we do not have to read the average. We have to reach percentiles, because if we read average, one part of the world, for example America, Instagram will be working great, but in Brazil it does not work great. So the average just messes up everything. If we read percentiles, we can find out where Instagram is lagging, where which server is having more load, whatever the issue is, we'll find immediately. Second, logs. Any event that we fire, for example, when we write a message or upload a reel, there are Kafka events that are firing. Directly, what we have to do, in each individual event, we'll have to put a detailed log, and that log, that tells you what happened inside the event if something misfires. For example, I upload a reel and it is not uploading since 2 days. The developer, how will he know? Or how will the team at Instagram know? Because you do not raise a complaint, it automatically gets fixed within hours. They know by logs what is going wrong, how the API broke, what part of code is broken, everything that is wrong, that is into the detailed logs. So those are very important when you are creating an app as such. And third, we get traces. Like traces are logs only, but they are basically logs on timing, where each trace has a timing. This app went down, or this part of Instagram went down. What time did it go down? What time did it get back up? By what time? What is it fix? These are traces we use to improve the app and make it run very smoothly to a lot of users. So now, if this is a question that is asked in many interviews, if you sit for a product-based companies, these are questions that you'll get asked very similar or very easily in many companies. They'll say they'll ask you to design Twitter or design Instagram in 45 minutes. So now that you've attended this session, you know what not to do. If you just they give you a pen and paper and you start, I'll code this in front end, I'll code that in back end, you'll get rejected immediately. That is not the process they are wanting to listen. They want you to clarify. For example, I ask you to design Instagram. You should have questions such as who will use Instagram? What features do I have to design? How many reads and writes per second? How, because these numbers, they are directly proportional to the changes of the design. So once these numbers are clarified, your design becomes very easy. Next, there will be separate read and write paths. Write path is basically a get request, and read is a basically a get request, and write path is a post, update, or delete request. So they should be very separate. A get request should have a different server altogether. Like I said previously, using sharding and using such techniques, and write path should be different, because they do not we do not want both of them to create a bottleneck together. And talking about bottleneck, we'll have to initially we'll have to name the bottleneck. So for example, there is an API that runs on every refresh. We'll have to name those bottlenecks, that this runs on every refresh, so there'll be a problem. This basically beats a diagram with 15 boxes that each and every box has no reasoning. Rather than that, you name the bottleneck and move forward. It is very uh, it is considered a good practice to do so. You'll have to say the trade-offs. You don't say you don't just say I'll use Redis. Why you use Redis? Because the like count can be a second stale, or a row log cannot take this writer rate. Any such proof of using a Redis is better than just saying, I'll use Redis for this technology, because the architecture and decisions, they come first and the technology comes later. So we'll have to design in such a way. If we are talking about apps such as Instagram, we'll have to talk about failures. If this part of code dies right now, how will it affect the app, and how we'll have to fix this? These are the two decisions we'll have to take before the app is even built. Not because the app will break, that's a definitive thing, but because if we have a plan, once if it does break, we know what to do and we'll fix the problem instantaneously. That is why apps such as Instagram, Twitter, and many more such apps, if a server goes down within 15-20 minutes, the server is back up, because they have a plan for every failure. That is how such apps are designed. And we'll have to finish with monitoring, metrics, logs, and everything. This will be measures for us, so that we can find out if something is broken, how fast we can find it out, and the gap that we can close by the time it is broken and the time it is back up again, that can be done using monitoring. So yeah, that was it in this session. And basically, if the next time, if someone asks you to design Instagram or design Twitter or an architecture of such kinds, you do not start with a front end and a back end. You start with trade-offs, you start with designs, you start with caching, you start with load balancing, you start with such topics, so that the app is designed to such an extent on a pen and paper that when you try and code it, it it does actually what you want, and it runs smoothly to many users. And you do not directly want to implement a feature. You want to implement it in such a way that when 10 million or 1 billion users also use that feature, it runs smoothly and doesn't just back down. So yeah, that is all from my side in this session today, and thank you guys.